Alright, we're doing some calculus, and we are looking at integration. This particular one here, we're going to be doing some definite integration, and we're going to be using the method of U-substitution. So we're going to show that this integral here is equal to 1/6, and we're going to do that by U-substitution, because that's going to be the technique that we're going to have to do in order to evaluate this integral. Writing the integral out, we're going from 0 to 1 of x times 2x squared minus 1, that's quantity squared, dx. And of course we're trying to show that this is equal to 1/6. And that's not going to be too difficult to do. So we're doing U-substitution, and earlier we did U-substitution indefinite integration, but this is definite, means we've got so we are defining our bounds here. Usually what's in parentheses is what we always let be equal to u, and then we want to take the derivative. Du is equal to, so this becomes 4x, and of course that's 0 there, dx. And instead of writing du over dx here, we just go ahead and bring the dx up over here. So as you can see, we have an x and a dx, but we don't have a 4, and so we're going to want to write a 4 in here, and I'm going to do that with a different color. So we put a 4 in here, but we have to put the 1/4 outside the integral. Right, must do that. Now we're going to go through and do part of this. There's something else we've got to do. I'll show you that here in just a second. So the 4x and the dx gets replaced with the du, and of course the 2x squared minus 1, right, we're going to replace that with the u times and then the du. Now there's one other thing that we need to do the substitution, and that is our limits here. So we're going to plug in 1. The way this is going to work here, you know, you can solve this U-substitution definite integration two different ways. You can go ahead and evaluate this without any limits, and then substitute the x back in like we did in the previous lesson, and then use these same limits here. But I think I find it just go ahead and doing the substitution for these limits, converting these limits over. So it's real easy to do. First thing we're going to do, and I'm going to label this as B here, right, because this is usually B and this is A. But all you have to do is plug this number in and get that out, and so that becomes a 1, right? So u b is 1, and then we want to do ua, and so this is 2 times, we're plugging 0 in this time, so this is 0 squared minus 1, and that becomes negative 1. Looks like a mu there. So we go ahead and write that in. So this is 1 and negative 1. Now we can go ahead and take this integral. So we have u cubed over 3, and we're going from negative 1 to 1. Right? Pretty simple. And if you'd like, we can rewrite this. This is u cubed over 12. Going from negative 1 to 1. Now we go ahead and do I plug the stuff in. So 1 cubed over 12 minus negative 1 cubed over 12. And so we end up with 1 over 12. And then this becomes plus 1 over 12. And so that becomes 2 over 12, and of course that reduces down to 1/6, and there you go. Something that's interesting, you graph that's a totally different graph than this up here. And that's what's really interesting, is how this, if you looked at this as area, gets transformed